Okay, so March 2020. I hope you guys have solved it.
सर स्क्रीन शेयर नहीं कर रहे आप.
Screen share नहीं हुई. Okay, sorry. Forgot about it. Okay. So it would be, it says define gravitational potential at a point. So gravitational potential is basically work done per unit mass. First of all, right? 1 mark. Second mark is work done per unit mass in moving a mass from infinity to a point in field. So that's what it is. Now it says unit mass. Now it says test and radius, Earth radius, whatever. The radius of Earth is this, the mass of considered point mass its center. It takes 137 days to orbit. Show that the radius of orbit test is this. Now, this is pretty simple. If I were you, I would use the equation. Like you could use anything really. But if I were you, I would use 4 pi square r cube, or if you remember, r cube equals to gm upon 4 pi square times t square. So you could actually, this is the Kepler's law. You could do that. So we want to find the radius. G is 6.67 times 10 raised to minus 7. The mass of Earth is 6.0 times 10 raised to 24. This is 4 pi square, and the time period in days, we should convert it because everything else is in seconds. 13.7 times 24 are 60 minutes, 60 seconds. Okay, and then you got to take the cube root as well. So yes, any question? Anybody did it? I think it should be the same, right? So 2.4 times 10 raised to 8.
मैंने FG equals FC उस तरीके से करा था. GMM over R square equals half.
MR omega square equals to GMM upon R square. ऐसे?
Yes, sir, मैंने भी ऐसे ही किया.
हाँ, तो सही आंसर तो ये. Okay. Then going to the next one says calculate the change in gravitational potential energy between tests in orbit and tests on the launch pad. Now we need to find the change. This should be calculated in a different way actually. So you should understand that there has to be potential at surface and potential at, say, tests, right? Now this is minus gm upon r at surface and minus gm upon r at tests, right? Now to basically find the change in potential, you got to do larger, this will be larger because it is gone far away, minus. So you take the change like this. Okay, I think so. Yeah. So then what you do? GM is the common one. So well, you could take gm outside, then 1 upon r s minus plus 1 upon r s, like this, right? This will give you the change in potential. So 6.67 times 10 raised to minus 11 multiplied by 6.0 times 10 raised to 24, and then minus 1 upon the distance of orbit. ये जो orbit था, it was 6. Sorry, test is 6. This plus the value we have calculated, right? Next thing, a launch pad and above. Okay. Wait a second. It doesn't make sense to me. Why? Okay, never mind. All right, so I'm gonna write अभी जगह मेरे पास कम हो गई है, so I'm gonna write it here. Times times the radius has to be. Can you please add? What will this be? 6.4 plus 6.4. अच्छा इसने radius this thing 2.4 into 10 raised to 8. 2.4 into 10 raised to 8 plus 1 upon 6.4 times 10 raised to 6. Okay, so this basically is the change in potential. And then if we multiply mass with it, this will give me gravitational potential, which is 360 दिया उसने. No, 360 Yes, I saw. That's it. He hasn't. Right. Wait a second. Where did he give the mass? I just saw it somewhere.
So it's 360.
6 times 10.
Yours is on there.
Where is it?
Sir,
It's the
B
first
part.
slide.
Oh my God. Oh yes. Sorry. वही मैं कहूँ नजर नहीं आ रहा. Okay. रोजा लग रहा मुझे. Okay. Now we find this. So what you do? Where is the calculator? So who did it? Anyone? इसका ये मतलब है कोई पेपर नहीं कर रहा आज. This is what.
2.17 10 raised to 10 आएगा.
2.17 times 10 raised to 10. Right. So
Answer मेरा थोड़ा different आया. मेरा 2.19 आया.
2.19 आया, फिर कोई चीज आपने राउंड करती होगी or something like that. But whatever, it's fine.
Okay.
Okay, then use your information, calculate the ratio. Gravitational field strength and gravitational field strength on this. Okay, we could do this. Gravitational field strength is given by gm upon r square. So this is on surface. Okay, we can write Earth and gravitational field strength on test. This is what we want, right? This and this will cancel out. This will come down. This will go down. So R on test and R on Earth. So ये तो हो जाएगा 2.4 times 10 power 8 whole square divided by 6.4 times 10 raised to 6. This is pretty simple. What is the answer then? आज मलिका नहीं आएगी ना, इसलिए हो रहा है मेरे साथ. That's why.
नहीं सर, मैंने सवाल किए हैं.
तो बोल किन रहे?
सर 1387.
1387. 1387 नहीं लगता ना. If this is the exact answer, you should give it into two significant figures. That should be 1400. Okay, is it clear? Now, let's go to the next question. The large container volume, this is filled with 110 kg of ideal gas. The pressure of gas is this. The mass of 1 mole is this. Show that the temperature of gas is approximately 300 Kelvin. Oh. Okay. So we have the pressure, we have kgs, we have volume, we have 1 mole. 1 mole, basically we have MR as well. Okay, that's fine. So what you do, show that the temperature is this. So we can use PV equals to NKT. Can we use that? NRT, sorry. NKT, NRT. Okay. So let's do 1.0 times 10 raised to 5. Volume आपके पास है 85. N is we don't know. R is 8.31 and temperature we want to find. So N can be found out, and it could be found out well if 1 mole is in 32 grams, then how many moles will be in 110,000 grams? So we're going to cross multiply. Divided by MR. So what was the moles? Yeah, we direct article.
3437.5.
Okay. Okay. Now you tell me the answer. Is this 3? What would be the answer then?
So 297.6.
297.6, which is approximately equal to 300 kelvins. Great. Now the temperature of the gas is increased to 350. The constant volume. Okay. The specific heat capacity of the gas is this. Calculate the heat energy supplied by heat. So the change in temperature we got is 350 minus 300. So that is 50 Kelvin is the change in temperature, right? And then we can use Q. Q equals to MC delta T. We want to find energy. Okay, that's great. 110 kg, 0.66, and this is 50. What was the answer?
3600.
3600 joules. Okay, perfect. Don't need to write it. Explain how the movement of gas molecules causes a pressure in container. Now, this is very, very easy O-level stuff. Number 1. Molecules keep colliding with the wall of container, right? There is a change in momentum. Force is exerted due to rate of change of momentum. And fourth point should be pressure equals to force over area. Hence, pressure is exerted. Okay. So this should be the ideal answer. Then it says the temperature of gas depends on the RMS speed. RMS speed of this, RMS speed of that. Okay, that's not difficult. I think kinetic energy is given by 1/2 mv square of mc square. उन्होंने कहा गैस का, so इसको हम गैस लिखना पड़ेगा. Nm c square equals to 3/2 nkt, right? So it says RMS speed. Okay. Well, if you see all, this is constant, this is constant, this is constant, 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 constant. So C square is basically proportional to T. So we could write C1 square over C2 square equals to T1 over T2. So C1 over C2 is equal to under root T1 over T2. Okay. What you do then? 350 divided by 300 under root. So easy. Yes. What you get?
1.1.
Okay. Okay. Now, a body undergoes a simple harmonic motion and state the amplitude. So the maximum would be this value. I don't think this is 0.05. 0.050. Okay, make sure you write it to significant. All right, then it says calculate the period of oscillation. Oh, okay, we could do that. I think we could do that. V equals to omega, V naught equals to omega x naught. I think we should use this, okay? Omega is 2 pi upon T x naught. So T will be equal to 2 pi over V naught times x naught. So this should be the case, right? So now let's check. X naught is this. V naught, we can check this. So I think 3.2, 3.4, 6, 8, 10. So it's 4.2. This is 4.2. 0.42. So let's do it. 2 pi divided by 0.42 times 0.050. And the answer is 3 marks for
0.75.
0.75. Please be very careful about the significant figures, okay? Make sure your answers are in minimum significant figures, which are generally 2 or 3 then. On figure 3.1, label point P where the body has maximum potential energy. At this point or at this point. Should be where this is, okay? Now, then goes part B. State Faraday's law of electromagnetic induction. EMF is induced due to rate of change of magnetic flux linkage. You can also write that is directly proportional or proportional. Switch is now closed. Explain why oscillation magnet are damped. Switch is closed. Okay. It's very simple. Now you have to write the Lenz's law. Right. So remember that the current in the coil is induced so which opposes the change of magnetic flux linkage. Now we need to write in terms of energy, right? So how do we write? We write the current causes heat energy to be dissipated across the resistor, right? And thus this energy is given by the oscillation of magnet. Okay, so you should remember this. It's very important to write Lenz's law and then explain how energy is being dissipated and why it is slowing down. Now, then 4a. So 4a is basically why ultrasound used in medical diagnostic is emitted in pulses. So for 2 marks, do remember that a pulse is reflected by every boundary and can easily be distinguished, right? So we cannot emit and detect wave or ultrasound at the same time. This is the reason it is sent in pulses. Explain the principle of the detection of ultrasound waves used in medical diagnostic, right? So we want to see how are they detected. When this question comes, you have to write that quartz or piezoelectric crystal is used. Number 1. Then you write ultrasound makes, we are talking about detection, right? If we had said how it is produced, then मैं इसको बताता हूँ कैसे लिखना है. Ultrasound makes crystal to resonate, and this vibration, these vibrations cause EMF to be produced across crystal. If he had said how it is produced, then you would write quartz and piezoelectric crystals use EMF is applied, or potential difference is applied, which causes the crystal to resonate. Then you write, hence ultrasound, the vibrations to and fro causes ultrasound to be produced, like that. Okay. Remember that. Up, this is air, gel, soft tissue. Calculate the significance of the fraction of ultrasound intensity that is reflected boundary between air and soft tissue. So the formula is already given, but you should remember this as well. So reflection coefficient हमने निकालना. So air is 4.3 times 2 minus, and soft tissue is 1.6 times 10 raised to 6. Wow. And 4.3 times 10 raised to 3 plus 1.6 times 10 raised to 6. And it should be whole squared. What was the answer then? Should be
0.999.
It's a 0.999. Okay, 0.99. So that is this. Okay. Use your answer to explain why gel is applied to the surface. अब इसका एक ही answer है. So you should write that the greater the difference in Z1 and Z2, the higher the reflection, विकल्प में बताया था, reflection coefficient, right? So you should always remember that, right? One. So with gel, the difference in Z2 and Z1 is very small, hence very less reflection occurs. So, or you could alternate write transmission occurs. All right, any questions, please let me know.
सर इस ऊपर पार्ट समझा देंगे दोबारा जो आपने ऊपर किया.
अभी यहाँ पे डिफरेंस तुम्हें था ना. So इसका कितना है? 99% रिफ्लेक्शन है. अगर डिफरेंस कम होता तो फिर ऑलमोस्ट इतना ट्रांसमिशन होती, तो अंदर भेजनी है, बाहर नहीं.
ये
Right.
है ना, मतलब कि ज्यादा रिफ्लेक्ट हो रही है.
जी, रिफ्लेक्शन कोएफिशिएंट.
ठीक है सर.
Now, state two advantages of transmitting data in. Oh no, this is not there. Now, two positively charged identical metal space A and B have their centers separated by a distance 24 centimeter. Okay. State the radius of the two spheres. Radius, I feel like it's 2, right? 2 centimeter, 2.0 centimeter. Okay. Radius आ गया. उसके बाद then it says charge in sphere is this. Determine QB. Assuming the charge A and B can be treated as point charges, explain your working. Oh, interesting. So E is equal to KQ over R. So charge in sphere is this. Okay. And the electric
E
field
equals K Q over R square नहीं होगा?
R square होगा. अभी मैं लिख रहा हूँ. 8 into 10 raised to 4 R है, right? And this is minus 2 into 10 raised to power. Acha. Oh, all right. That's fair. ठीक है, अभी कर लेते हैं. So, well, let me think about it. ऐसे करें, इलेक्ट्रिक फील्ड स्ट्रेंथ का फायदा क्या होगा? चार्ज तो मिलना नहीं है. So, अगर हम इस पॉइंट को देखें, here the electric field strength for both of them is 0. इस पॉइंट के ऊपर it will be KQ over R square equals to KQ over R square. This is better. So what you do is R. From this to this is 16. And from this to this, it is 16 minus 24 is 8. 8 centimeters. Okay, so we can do this.
सर वो 14 नहीं होगा फिर.
Huh?
ये वाला
24 minus 16 is 8. 14 guess होगा. 0 minus 6, 0 to 16 is 16. सेंटर से लेते हैं, सरफेस से नहीं लेते.
ठीक है.
So इसका 16 था, 0.16 लेना पड़ेगा. And then this will be QB divided by 0.08. Okay, can you please tell me the answer?
9 times 10 power minus 10.
9.0 times 10 raised to minus 10. Please do not forget this. Now, sphere B is removed. Use the information to determine the electric potential on the surface of A. Oh, so we have the charge, right? So V is equal to KQ over R. So 8.99.
Sir.
Yes.
Sir, in the previous part, is it okay to use E equals to F divided by Q formula?
But how would you find F then?
Sir, we have E, we have Q of A, so we can find F.
Okay. So how would you equate them?
तो Q
Uh,
सेम होगा ना? वो कैंसिल हो
नहीं
जाएगा.
कर सकते, equate नहीं कर सकते. Lisa, no. That's wrong.
but
So
sir,
force
but sir, जब
same
हमारे
ही
पास F आ गया तो हम लोग उसे कर तो सकते हैं by equals to V divided by D.
तो F दूसरे का कहाँ से आ गया आपके पास? इसका कहाँ से आ गया?
Oh yeah.
B
तो
का
इस
तो
पॉइंट
F
पे
है.
सेम नहीं होंगे.
इस पॉइंट पे F0 होंगे. ये भी इधर है, ये उल्टा है. 0. आंसर 0 आ जाएगा.
मतलब ओवरऑल फोर्स 0 है ना.
ओवरऑल 40 है यार. तो फिर तुम ऐसे लिखोगे F निकाल के A का, Q भी A का पता है और इसका अननोन है, इसका भी अननोन है. दो अननोन
नहीं
के
सर,
सॉल्व होते.
मैंने EQ इक्वल्स F करा था.
वहां पे फिर EQ लगाओगे, इक्वल लगाओगे, E भी 0, यानी E दोनों के इक्वल हैं, तो ये कैंसिल हो जाए. हाँ, तो वो सेम आ जाएगा, फिर तो गलत हो जाएगा.
हाँ सेम.
नहीं हो सकता.
ठीक है
That's
सर.
wrong. Now, use your information to determine the electric potential. Okay, वो A की सूरत सरफेस. What? अच्छा, electric potential में निकाल रहा था. And then R has to be 0.0 because the surface में निकालना है. So what is the answer then? Who's gonna tell? 1600. Okay. Then calculate the capacitance. Q equals to C Q upon. Charge is 3.6 times 10 raised to 9. Okay. And what is this? Farad.
2.3 times 10 power minus 12. सर
Minus.
पार्ट CI में इलेक्ट्रिक फील्ड स्ट्रेंथ टाइम्स रेडियस कर सकते हैं.
No.
तो आंसर सेम ही आ रहा है.
Electric field strength ऊपर से और radius. Maybe, I don't know. करना तो चाहिए.
फॉर्मूला KQ over R square है, टाइम्स R करेंगे तो V बन जाता है.
हाँ, ठीक है. You can do that too. Okay. Then next. On temperature characteristic. Oh, this is not there. Yes, में चला गया. Unfortunately, this was such a good chapter. Okay, explain what is meant by magnetic field. Magnetic field is a region where a moving charge feels a force. You can write another magnet, current carrying conductor. Now, okay. All right. Calculate the magnetic flux density. So you have force and current, right? So F equals to VIL. We have the length. We should have length, right? That is 45. Length is 45 actually. The effective length we always take, okay? 45 क्या था वो? Centimeter, millimeter.
Millimeter है sir.
Okay, you can take any force, then you can take this force 5 and this is 9. So 9 times 10 raised to minus 3. B, current is 5 and the length is 0.045 then, right? So B is
0.04.
0.040.
सर जब ऐसा कभी हो तो जीरो ऐड करना चाहिए मतलब
जी, क्योंकि आपका
significant figure के
आप
वजह से।
आंसर टू सिग्निफिकेंट होना चाहिए क्योंकि आपका मिनिमम वैल्यू टू सिग्निफिकेंट है.
सही है।
Okay, then in a different experiment, electron accelerated through this inter-region magnetic field. The magnetic field into the plane of paper and the perpendicular direction. Okay. Explain why the electrons flow in a circular path when inside the region of magnetic field. Because force is always perpendicular to direction of electron's motion, or you can write velocity. Okay, so ये कितने मार्क्स के लिए लिखना है? 3 मार्क्स के लिए. Okay, for 3 marks you got to write since F equals to BQV, magnetic field provides centripetal force, right? So it moves in a circle with constant speed as magnetic force is constant. Please do write it. Now, state the measurements needed in order to determine the charge to mass ratio. So basically, you got to remember VQV equals to mv square over r, and r would be equal to BQ over mv. So these are the measurements required, right? So what do you need? You need radius.
और बी भी चाहिए होगा
Radius, circular path, of course. We need magnetic flux density. We also need current, you know. Yeah, I don't think so. करंट की जरूरत नहीं, चार्ज हमारे पास है ना, चार्ज तो है, मास भी है, बस यही चीजें चाहिए होंगी, और स्पीड उसने कहीं ढूंढने के लिए ना, चार्ज टू मास रेशियो ऑलरेडी ढूंढनी है, चार्ज टू मास रेशियो ढूंढनी है, सो स्पीड भी चाहिए. स्पीड निकालने के लिए ना फॉर्मूला है VQ equals to half mv square. ये वेलोसिटी सिलेक्शन करते हैं, मतलब ये वेलोसिटी काइनेटिक एनर्जी देने के लिए. So we also need potential difference to find V. Okay, that's what you need. Then the output power is represented by this, where P is the potential difference seconds. Determine the output supply RMS. So the V naught is 9.0 divided by under root 2 will give us V RMS. So the answer is
6.47.
6.4. Yay! Now, the time period, omega equals to 2 pi by t. Omega in this is 20. So t equals to 20 divided by 9. 2 pi divided by 20. Now you might be wondering, how do I know this? This section of the equation is V naught. This is omega. Yes. Okay, the answer is
0.31.
0.31. Great. Now, this is potential difference power supply. The graphs are drawn to same stating whether the same power will be dissipated to each power supply. एक हमारे पास वो है और एक वो है. याद रखना, always remember, इसकी RMS different होती है, इसकी RMS हमेशा निकालते हैं हम V naught over under root say in a sinusoidal way. In this one, we have to take, we do V square and then area under the graph and then mean differently, right? So both root mean square is different, hence different power. Different power. Okay, so you remember. Now, so
सर
the
ये
power.
स्क्वायर वाले में एरिया ऐड करके बस डिवाइड बाय 2 करना है ना?
नहीं, इसमें. Let's suppose this is like 4. Okay, this is 4. This is 1. This is 3. Then this is. Okay, let's take it 2. Right, like this. 2, 3, and so on. So the first thing is you square this. So 4 का square क्या हो जाएगा?
16.
ठीक है. और उसका भी जब 4 को स्क्वायर करोगे ना तो ये एक स्ट्रेट लाइन आ जाएगी इस तरह. Do you understand?
समझ रहा हूँ.
यानी जो इसका ग्राफ बनेगा ना, it will be 16. ये v naught square हो जाएगा. Okay, like this 1, 2 and so on. Then what you do is you multiply. जैसे 16 आ गया था, so 16 into 1 plus 16 into basically whatever that is. All right, 1, and then you divide by the total, which is 2. So कितना हो गया? 16 plus 16 is 32. 32 divided by 16. Do you understand this?
सही है सर.
So ये 16 आ गया. अब क्योंकि ये v naught का स्क्वायर रहता है तो अंडर रूट ले लेंगे. जब रूट लेंगे तो इसकी 4 आ जाएगी. 4 ही इसकी RMS है. Right? Is it clear? So basically, it's like the mean. You're taking the mean. Okay.
सही है.
So इसमें ये करना होता है, but I don't think so he's going to. Yeah. Okay. Maybe he will. All right. So power supply is connected to transformer. The input transformer is 80 watt. The secondary coil is connected to resistor. The RMS voltage across the resistor is 120. The RMS current is this. Okay. What is the efficiency? The power supply, the input power is this. So power input. Secondary coil is resistor. The RMS of the resistor is 120. So VRMS is 120 and IRMS is. So PRMS, I mean mean power is going to be 120 times 0.64. You guys agree? You guys agree?
जी सर.
बताओ फिर आंसर बताओ इसका क्या है. ये कितना आता है?
सर ये आता है 76.8.
This is the power. उसने कहा जो power supply हमने दी है. Input power. अब I don't know if this is the. अच्छा ठीक है. This has to be the mean power ही होगी. So 76 in output divided by input multiplied by 100%.
96.
0.96.
Okay, so both are correct. State one reason why transformer is not 100% efficient. That is because of usually in transformer there are eddy currents. Eddy currents in core causes heat loss. Okay.
Is it okay to just write eddy current and not give the full information?
No, that would be wrong. You have to understand that there has to be some other thing.
Okay.
Okay.
Yes, sir.
All right then. By reference to photoelectric effect, explain what is meant by work function energy. So work function is the minimum energy required by metal to remove electron from its surface. Yay! So easy. Then this graph is given. It says determine the work function. So what you do, you have to extend this line, by the way. And be very careful, do it nicely, like this, right here. Okay, we extended it. Now, this is frequency, and where it touches, somewhere here, right? This is the threshold frequency. You got to remember that. Okay. So threshold frequency, आपके पास आ गई. I don't know what this is. This is somewhere in the middle, right? So, or somewhere like this. So this is 5.1, 5.2, 5.3, 5.4, 5.45. So 5.45 times 10 raised to power 14. Okay, this is F naught. So work function is equal to H F naught. 6.63 times 10 raised to minus 34 multiplied by 5.45 times 10 raised to 14. So the answer is
3.6 to 10 raised to power minus 19.
3.6
into 10 raised to power minus 19.
Okay, good. Now it says determine the metal used in experiment, show your working. So they have given the work function in EV. अब आपको only you need to convert this in EV. 3.6 times 10 raised to minus 19 इसने मुझे बोला, ठीक है. So 1 EV equals to 1.6 times 10 raised to minus 19. Then how many EVs would be 3.6 into 10 raised to minus 19? Cross multiply. And it would be
2.3 EV.
2.3 EV. So the answer will be potassium. So now the intensity of electromagnetic radiation, one particular frequency is increased. State and explain the change in any in the maximum kinetic energy. If the frequency increases, right? So the photon will have the intensity. Intensity doesn't increase frequency, right? So it doesn't really matter. Intensity means more photons will come per unit time. So I would write no change as frequency remains same, hence photon energy. Photon energy is not dependent on intensity, by the way. And rate of emission increases as intensity equals to energy over time over area. So intensity is 1 upon time. So what will happen? Increasing intensity will reduce the time. So rate of photons reaching metal increases. So does rate of emission. I hope you guys understand this, right? Okay, then going to the next question, which is 11. Electrons are accelerated through potential differences. They are incident on a metal target. They decelerate X-ray photons emitted. Calculate the maximum possible frequency. So you have the potential difference. If all of this energy converts to, highest jump, then you could use, interesting. We need to find frequency. We have kV. We have voltage, but we need energy, right? HF. Energy can be found by BQ. So 100,000 times 1.6 times 10 raised to minus 19 equals to 6.63 times 10 raised to minus 34 times 10. So what is that? Yes.
सर F मेरे पास जो आ रहा है वो है 2.41 10 raised to power 19.
Okay. Now explain why aluminum filter may be placed in X-ray beam when produced by X-ray image of patient. This is very important because you need to understand that X-rays have many wavelengths. First, right? So low frequency or high wavelength increases absorption, right? And does not contribute to image, because image contribution will be when some of it, really just goes through. So aluminum filter absorbs low frequency X-rays. Is it clear? 3 mark. Now they have given you the linear absorption coefficient of bone, blood, blah blah blah, and they say the beam of X-rays is incident on a person. Calculate the percentage intensity of X-ray beam that has been absorbed after passing through 88 centimeter of blood. So intensity equals to I naught E minus mu X. That is the formula. You should remember this. So we want to find the percentage. So I'm just going to divide this. E minus mu of that is blood is 0.23 and X is 0.80. So what is the answer? Can you guys guess?
83%.
Sorry?
83%.
83% is going to be transmitted. Right? So how it says how much is absorbed? 17%. Is it clear, everybody? If the new intensity is just 83%, so it means only 17 would have been absorbed. So remember this. Then it says in X-ray image, white regions show greater absorption of X-rays than dark regions. State and explain the difference between X-ray image of bone compared to that of muscle. So in bone, it is a higher absorption coefficient. So bone is lighter and muscle will be darker. Right. So we would say bone has higher absorption coefficient mu. So bone will be darker, bone will be lighter, and muscle darker. Is it clear? Right. Then going to the next. What is meant by binding energy of a nucleus? Okay, so binding energy of a nucleus is basically the energy required to disintegrate a nucleus into required to separate nucleus to its nucleons to infinity. Okay. Now, determine the values of x and y. Okay. I guess we can do it. 235 plus 1 equals to 144 plus 90 plus y into 1. So that would be, क्या आ रहा था? No,
37.
37 आ रहा है?
नहीं सर सिर्फ 7 आ रहा है y पूछ रहे हैं ना
मैं सर x की बात कर रहा
हाँ सर y तो 2 है
हूँ y2
Y. Okay. 92 plus 0 equals to 55 plus x plus y into 0. So x will be, कितना बोला? 37.
हाँ
yes.
Right. Okay. State the name of type of this nuclear reaction. It has to be fission, because heavier molecule is breaking, right? So compare the binding energy per nucleon of binding energy nucleus cesium. So definitely binding energy per nucleon of uranium is smaller than cesium. Okay. Yttrium, 90 degrees of zirconium. Okay. A sample initial consists of pure this. Calculate the time in days when the ratio of number of yttrium nuclei to number of zirconium 90 would be 2. The half-life is this. अच्छा, wow. ये तो बड़ा important सवाल है. Yttrium decays into zirconium. Calculate in time in days when ratio of number of yttrium nuclei to the number of zirconium would be 2. So yttrium to zirconium 2 का क्या मतलब है? 2:1 कह रहा है. Yeah, this is what he's saying. Okay. Okay. So 2 into 1, इसका मतलब ये हुआ we can make a ratio of anything like, you know, something like, पहले तो you tell me what is lambda. Lambda will be ln2 over 2.7. Can you find this? What might this be?
3.895
सर 2.7 को हम कन्वर्ट नहीं करेंगे
2.7 को नहीं डेज में आते डायरेक्टली बताओ डेज नहीं आते 3.895. ओके. अब अगर हम देखें रेशियो में टोटल रेशियो जो होती है हमारे पास दैट इज 2 + 1 3. And what do we want to find? We want to find what happens to y. Because y का
Sir?
given y. Yes.
Am I the only one जिसका lambda different आ रहा है?
I don't know. You guys
Yeah.
can. What is your
It's-
lambda?
0.5.
0.5. Okay.
25.
0.25. Okay. So conflict means that today I have to do it. So
0.26 आ रहा है
Basam, who are you going to bet?
हाँ सर मैंने गलत करा
0.226. Wow. Lisa is right. Okay. Now, if the total is 3 and we in 3, 2 is remaining, then we can say activity. नहीं number है. N equals to N naught E minus lambda T. It is 2. Total was 3. Lambda is 0.26 and we got to find the time. So ln 2/3 equals to minus 0.26 times t. And the answer is divided by minus 0.26. It is 1.56 days. So
तो
about
आपने
1.
ये कैसे डिसाइड करा कि n नॉट 3 होगा?
Because in a sample, when you take out ratio, right? So what is the y? If I say after certain time, right? So you see that y upon z was 2, right? You agree, right? So y is 2. I'm saying that if after some time y was remaining 2, so 1 was z, right? So total would be 3. This is how we take ratios. So ratio of y, so change in y over y would be 2 upon 3. So initially y was 3, right? Then it decayed into 2, like this. So Yogya, and ta-da, finish. Cool. You guys have any questions?
Yes,
Lisa,
sir.
Nahid.
Question 6.
Question 6. Okay. Ooh.
So you
Question
can
6.
stop the record.
Okay, yes, I can.